Welcome to our video on finding the main points of a parabola, which is a summary of all of our work so far on graphing parabolas. Before we start, a few things to remember from previous videos. The first one is the three different forms of a quadratic equation. We've got expanded form that looks like this: y equals ax squared plus bx plus c. We've got factorized form that looks like this: x take away b, so it's fully factorized in its two brackets. And we have turning point form, which is y equals plus or minus a x minus h squared plus k. Second thing I want to take you back to are the main points that we need to label when we graph a parabola. I've got them numbered here. The first one you need to label is the y-intercept. Actually, I might draw this a bit further over here so you can see it clearly. So this could be your parabola. There we go. Y-intercept will be here. X-intercepts are here, number 2, and number 3 is the turning point, and you must label those with coordinates. So for example, one number, comma, another number, make sure it's in brackets. Okay, this video is going to be a summary of the many different ways you can find each of these 3 points. If you would like some further information on how to do each of these, I would recommend going back to one of the previous videos to have a look at how you might do that. So the first number here is the y-intercept. So I have find a y-intercept. These are some of the many different ways. You can choose whichever way works for you, or whichever way is the easiest based on the type of form you have for your quadratic equation, one of these 3 forms. Finding a y-intercept. The first way you can do it is by making x equals 0 and substitute x, so everywhere you see x in the original equation, you put 0 in, and then you'll find your y-intercept. A second method is to just read off the constant, which is the number at the end, when your equation is in expanded form. So I'll just put expanded form out here again. Ax squared plus bx plus c. So the plus c is your y-intercept. The last method you can use is from factorized form. You can just find y equals a times b. So a reminder, factorized forms looks like this: x minus a, x minus b. So you just need to multiply these 2 numbers together and you'll get your y-intercept. The second number of points we need to find is the x-intercepts, and this is probably one of the hardest ones people find. There's usually 2, sometimes there's 1, and sometimes there's 0 x-intercepts. The first way I've got here, if you have your equation in factorized form, which is this one here, you can use the null factor law to solve this equation and find out what x equals. Second method, you could, in any form, you can make y equals 0 and then solve the equation. So if it's in expanded form, you'll need to factorize it first and then use your null factor law like we did in step 1 up here. I've put some information down here about factorizing, just to remind you the different methods you can use. Always, always, always try your basic factorizing first. A lot of people try to go down to completing the square or one of the harder methods, but if you can do it in one step, it would be much faster to do that. So start with basic factorizing. If you can't use that method, you can try DOPS, which is this one, x squared minus a squared, difference of perfect squares, difference means minus, is x minus a, x plus a. If it won't work with either of those two methods, then completing the square would be an option. Or the final method, particularly if you have a coefficient of x squared, a number in front of the x squared, then you can use the AC or the cross method. That's only something that you need to know if you're in extension maths. So that's how you can find the x-intercepts. Finally, I want to look at how you can find the turning point. This is a two-parter. Firstly, you need to find the x value, and I'll go through some options here for how you can do that. And then, once you have the x value, you need to substitute that into the original equation to find the y value. So your turning point will look like a coordinate point with two numbers in it. This is the x value, this is the y value. So let's look at how we can find the x value. One method is to find the halfway point between the two x-intercepts, and you might draw a number line to help you work out if it's between, say, -2 and 5. You might draw a number line and put the ticks in between and work out where the halfway point would be. Second method is to use x1 plus x2 divided by 2, which would be take those two x-intercepts, add them together and divide by 2, and you'll find the halfway point. The third method is to use x equals -b over 2a, which you can use when your equation is in expanded form. Once you've got your x value, remember to substitute in to find the y value, and then you have your 2 points that you can plot on your graph. If you have your equation in turning point form, then you can just read it straight off. So let's remind ourselves about turning point form. Plus or minus a, x minus h squared plus k. The turning point is at h. Remember, it's the what's inside the brackets. We change the sign, so instead of minus h we make it h, comma, k. So you just read these two numbers straight off and you've got your turning point. You don't have to do all this halfway stuff, just use your turning point form. And you could find, if you back here in step 2 we're using completing the square, you would have as one of your steps, turning point form would come out about line 3 of your working out, so you can just read it straight off there. So it's kind of a 2-in-1 situation. Hopefully this video has given you a bit of a summary for how you can find the main points that you need to graph on a parabola. Remember, if you would like some information on how to do each one, take the time to go back and review the previous videos. Thanks for watching today.